Everybody, today we are going to be learning about stoichiometry. Stoichiometry is one of the hardest subjects, but we're going to get through it easily. First, we need to understand the molar ratio. The molar ratio is a ratio of each coefficient in the reaction. We learned last unit that coefficients are used to balance reactions. Well, each coefficient is going to represent the moles of the substance it is next to. Let me show you what that means. So in this reaction, we have coefficient of 2 here, coefficient of 2 here, coefficient of 3 here. Well, last unit, we didn't really understand what these coefficients are for. You only thought they were for balancing. Well, nope. This time, we learned that this means there are 2 moles of this, 2 moles of that, 2 moles of that, used in every single time this reaction occurs. So, when this reaction occurs once, 2 moles of KClO3 will be used to produce 2 moles of KCl and 3 moles of O2. So the ratio is basically 2 to 2 to 3. That's literally how simple it is. It's just the ratio of coefficient to coefficient. That's basically it. Now they're asking if we use 44 moles instead of this 3, what will be the number here? How much of this will we produce? Oh wait, sorry. How? no, no. How much of this will be produced? This is the reactant, I apologize. How much of this will be produced along with this? So if we had 44 moles of this, remember this 3 represents moles, 44 moles of this, how much of this would we have? So first, we need to identify the number of compound and number of moles given in the question. 44 moles, that's what it's given. My friend Uche has laid out this in a very simple, very easy way to follow. To give huge thanks to him. Then we identify what they're asking for. They're asking for moles of potassium chloride, that'll be moles of KCl, and then we just found the molar ratio, which is 3 moles of O2 and 2 moles of KCl. So we have our problem. How many moles of KCl in special analysis will be produced along with 44 moles of oxygen? So now all we have to do is use dimensional analysis. So we have this set up. So now we're going to multiply by the molar ratio, which is 2 moles of KCl per 3 moles of oxygen. We want to cancel oxygen, so we put it on the bottom, and we want KCl, so we put it on the top. So the 2 from there goes there, 3 from there goes there. And when we put this in the calculator, and we get 29.3 moles of KCl, which means that if 44 moles of oxygen were produced here, then 29.3 moles of KCl would also be produced. Easy, right? What about for grams? Well, grams is easier. So we've only had moles so far, so we just only did this. So for grams, you would convert to grams to moles, then do this, and then convert back to grams. So we put moles on top because that's what we want. Get rid of the grams on the bottom. Do the step we just did. And then you would convert back to grams by getting rid of moles and putting grams at the top. Molar mass on some periodic table. Always remember that. So Ruscia has put another nice example for us. How many grams of chlorine would it take to produce 76 grams of NaCl? So remember his step. First we find what they gave, 76 grams of NaCl. So you put that there. That is what is given and how much we want. That's the question mark grams Cl2. So we're given 76 grams of NaCl. So what do we do first? We convert to moles. So we can use the molar ratio. So we know 1 mole NaCl is 58.44 grams NaCl. How did I know that? Well, that's the molar mass of NaCl in the ratio of 1 mole. So now this is converted to moles here. Then we use the molar ratio to Cl2. So there's 1 Cl2 and 2 moles NaCl. And we want to get rid of NaCl and we want chlorine. So we put chlorine on the top, NaCl on the bottom. And then we have our answer, but that's in moles. We want it in grams. So we put the molar mass on top because that's in grams. And we put the moles of Cl2 on the bottom, giving us 46 grams of Cl2. Another example here. This is very important, by the way. 21 grams of ethane burns. How much moles of water we produce? This is simpler because they're not asking you to convert back to grams. Basically the same process. Uche said first start with what you're given, 21 grams C2H6. We want to get rid of gram C2H6, so put its molar mass on the bottom, put 1 mole on the top. So now this is in moles, and then use a molar ratio. 6 moles H2O, which we want, to 2 moles C2H6, which gives us 2.1 moles H2O. Simple, right? Look how nicely it laid this out for us. Now, what happens if you limit the amount of reactants that you are having in the reaction? What happens if one reactant runs out? How many times could the reaction occur? And more importantly, how much product would it produce? Well, we first need to find the limiting reactant, the one that is making the reaction not able to run so sustainably. So the limiting reactant can be found by the one that produces the least product when calculated with the molar ratio. By this we mean multiply each reactant by the molar ratio to the product. So we put the product on the top and the reactant on the bottom in the molar ratio, and we found out how much product would moles of that reactant produce. The one that produces the least moles is the one that is going to limit the amount of product produced. And the one that does not limit is excess. The excess that is used, we are going to convert the limiting reactant by multiplying its molar ratio to the excess. That might sound a little convoluted, so let me put an example for you. Imagine you need to make a cake. For a cake, you use 2 cups of flour and 1 cup of sugar. You have 8 cups of flour and you have 4 cups of sugar. Okay? No, let me rephrase it. You have 6 cups of sugar, not 4. How many cakes could you make? Okay, so we have 8 cups of flour, 6 cups of sugar, but every one cake uses 2 cups of flour and 1 cup of sugar. So when you look at the sugar, you could make 6 cakes. But when you look at the flour, you can only make 4. So can you make 6 cakes? Oh, because you only have that much of flour, you can only make 4, including the sugar. So the limiting part is the flour. However, you would still have some sugar, some sugar left over, because you only use 4 cups of sugar. That would be 2 cups of sugar left over. That is the excess remaining. Now let's apply this to elements and reactions. So 2 sodium plus chloride into 2 is these 2 NaCl. Now, if you had 15 moles of Na, 7 moles of Cl2, how much NaCl will be made, and what is the limiting reactant? After the excess reactant remains. Remember what I said here? Multiply each reaction by the molar ratio to the product. So we're going to do that. We are given 15 moles of Na, put that there. 7 moles of Cl2, put that there. Multiply each by the molar ratio to the product. So 2 moles NaCl on the top, 2 moles NaCl on the top for both of them. On the bottom, we want to get rid of each individual element. So 2 from there, 1 from there. That gives us 15 moles NaCl produced. That gives us only 14. Remember the flour and the sugar? Can we really make 15 moles of NaCl? No, we can only make 14 because that's the least amount produced. We cannot magically get more Cl2 out of nowhere to produce 15. No, we have to stick with what we have. We can only produce 14. So limiting reactant, that would be Cl2. How much NaCl will be made? That would be 14 moles of NaCl. Now to find excess remaining, we find that we have already used up all the limiting reactant. Remember, you used up every single mole of the limiting reactant, right? So now we need to find out how much of the excess we did use up. So we convert this to the excess by putting 2 moles of Na on the top, which is what we want, and getting rid of the 1 mole Cl2. This is another molar ratio. I told you it was important. 7 times 2 divided by 1 is 14 moles sodium used. Sodium, remember, was the excess reactant, and Cl2 was limiting. But we used 14 moles of sodium, right? But they gave us 15. So we would just do a simple subtraction problem and find we have 1 mole sodium remaining. Got that? Good. Finally, we got percent yield. Percent yield is the given amount of a substance produced over the calculation for the molar ratio. So what that's basically saying is the actual amount produced in an actual live reaction experiment over the amount you calculated on the paper. So like, let's say for the flour and the sugar, you calculated that you could make 6, right? What if you only made 5? You never know what could happen. Like, I don't know, some flour, sugar spilled over or something. You only made 5. Well, that would be the percent yield, right? That would be how much the percentage of the thing that you could have made, but the thing you actually did make, right? So like, you made 5, but you could have made 6 according to the calculation. So 5/6, that would be the 5/6 times 100, that would be the percentage. So, but to find theoretical, well, how do we do that? We have to calculate. So we convert the grams of the limiting reactant to moles and convert that to moles of product to use a molar ratio. Convert that to the grams to find theoretical yield, blah, blah, blah. This we have already done. Right here. That's basically saying the same thing. We convert grams to moles, find the molar ratio by converting the limiting reactant to the moles of product. Let me show you what I mean. 80 grams of KCl is reacted with excess oxygen. So, stop. Wait a minute. What is the limiting reactant? KCl? Yep, because we have excess oxygen. What would be the theoretical yield of the product? So they give us, remember what Ruche said, put what you are given first. 80 grams KCl. We would convert that to moles. Remember, convert to moles, right? Convert that to moles with molar mass on the bottom, 1 mole on top. So we have moles of KCl. This has become moles now. So now we need to convert that to how much product we could produce. So we see for every 2 KCl, we can produce 2 KClO3. That's the molar ratio. So 2/2. 2 mole KClO3, 2 mole KCl. You get the gist of it. Now we just have to convert back to grams as they are asking for grams. So we put the molar mass of KClO3 and 1 mole KClO3 on the bottom, which gives 131 grams of KClO3 we could produce. So in this reaction, if you've had 80 grams of KCl, you could produce 131 grams of KClO3. However, they only produce 120. 120 over 131 grams, remember this, is 91% yield. Thanks for watching. Special thanks to Ruche, and see you in the next one.